So the next presentation will be about rapid development of a data analytics application in Node.js. I'll be giving a talk together with my colleague Jan Rupnik, and I'm Blaz Fortuna. We come from a research institution, actually, so from AI Lab, from Jozef Stefan Institute, and we are also working as research contractors with Bloomberg. So we are sitting on kind of two chairs, and we'll be going through. We'll be talking about how to develop these data mining applications. So let's start. So what is a typical data mining workflow? So this is very simplified, but standardly we would have so this is just to get us started. Typically we would have some raw data on the input. So to continue from the previous talk, we can start with the raw input being Twitter data. Then we load this data in, either download it through APIs, either get it through some other means. We load it into some and represent it in some a bit more structured way. For example, store it in a database. And then for doing any kind of data mining, machine learning on top of the data, first we would extract some mathematical representation depending on the methods we want to use, and then derive some machine learning model. So to make it a bit more concrete, so this is one example. So we start with one tweet. So here tweet is cats are totally amazing. First we would want to load it. So go to the using, for example, tweet npm module, download it, store it in some local storage. Here we have only two fields. One is text, so what is the raw text from the tweet, and a sentiment, which we don't have at this point yet. Then we extract some mathematical representation of the tweet. So here we use something called bag of words model. So we identify all the words that occur in the tweet and assign them some weights depending on the corpus we saw so far. And then we can do predictions on that. For example, we can say, okay, that tweet obviously has a positive sentiment. Now, let's switch to Node. So why? So there are lots of platforms, very well-known standard platforms for doing data analytics, for example, from Python or from all Hadoop stacks. So why go into Node.js to do data analytics applications? So one very important thing is that it's very easy to build complete verticals in Node.js. So starting from data acquisition, so taking in some data either from sensors, so we saw today from Internet of Things sessions, either from web APIs, load them, get them into the application, and then expose them to the user, do something on them, and then expose it to the user either through RESTful APIs, either through some UI. Node has a rich ecosystem of components that support us at all of these stages. For example, they support us on data acquisition and sending this data to other APIs. There's a very nice application frameworks to work with, and it runs on many platforms. So either standard desktops from Linux, Windows, so on. You can run it on cloud, and it can also run on what we call data-friendly platforms, so like Raspberry Pi. So this Internet of Things-like devices where you have on the same machine you're doing data acquisitions through sensors, and you can have enough processing power to actually do some crunching as well on there. Now, what are the cons of doing analytics in Node.js? So just doing, for many more heavy numerical stuff, pure JavaScript is not so suitable. So here is one small example. So doing matrix-to-matrix multiplication on several sizes of matrices, of square matrices. So the blue one is just implementing matrix-matrix multiplication in native JavaScript. Then one lower is using it via native add-on on Node.js, using some kind of naive C++ code. And the lower one is hardware optimized, so using Intel MKL, for example, MKL library for doing matrix-to-matrix multiplication that takes into account the actual processor and its operations it has. So you can get it down from 12 minutes to a couple of seconds. So it matters. These things, when you're dealing with large data sets, can have a big impact. And what we will be showing today is one module we call QMiner, and it's a native add-on for Node.js, and it allows, it's built to support fast development of integrated data analytics applications, meaning that you can go from data acquisition to modeling transformations to user interfaces, all within Node.js. It has a couple of native add-ons, native support. So one is scalable data structures. So you have C++ implementations of vectors, matrices, hash tables, graphs, and so on. It has a C++ implementation for various data transformations, whether we're working with text, with social networks, with data streams. And it has a wrapper around this industry standard linear algebra packages like Blaz or LAPAC. So you can do fast numerical computation on top of these structures, and support for a couple of standard machine learning algorithms. And it's open source. So the way we'll show this is through 2 use cases. So one use case is Twitter sentiment classification. So starting from tweets, training a classifier to predict sentiment on tweets, and the other one is user profiling and recommendation. So the first one will be done by
Okay, so let's see how this a very standard problem from machine learning. So building a text classifier, in this case to detect sentiment in tweets, how this can be realized using QMiner module. So here we start with a data set where we have 1.6 million tweets that were gathered by just using the Twitter API, streaming API. So just looking for tweets with a smiley face or tweets with a frowny face. So so these are here we have 2 examples of negative sentiment tweets. One is, "Why aren't you answering me on Skype?" And the other one is, some guy who ran out of cologne. So the point here is that these messages these signals are actually pretty weak, but the idea is that if you have 1 million of such messages, that you might be able to build a model that captures the sentiment of users. So and the other thing to mention is that emoticons are stripped away from the messages, because otherwise the learning would not really work. So this data set is published at the URL below, and all we took for our purposes here are just the sentiment, the target, and the text. So the next thing I'll show you is something, an example, which is a tonic notebook. So you can run it, clone it. There's the URL. You can clone the notebook online and run it yourself in the cloud, or download the notebook. Okay, so just a moment. Okay, so to build the classifier, first we have to import 2 libraries. One is QMiner, so that's at the top. Require QMiner, and then there's a helper library that's just there for us to load the data. So require QMiner data loader. The next thing we do, as Blaz mentioned, the second step, the first was raw data. The second step is defining some sort of schema for storage. And in this case, we just define that our table will have 2 fields. One is text and the other one is target, and that's it. In the next step, we import data and select all the records. So in this case, we have a really small sample of only 2,000 tweets. Now at the top we print the first tweet. So this tweets variable contains all the records, the tweet records, and the first one .text gives us the tweet. Next we print the target, so it's a negative sentiment tweet. Then here comes the third part in the typical workflow. So we have to define the mapping that turns so raw data, text in this example, into mathematical structures. So in this case, sparse vectors. So here this is just to show you how defining this mapping looks like. So we just set up a standard processing this bag of words feature extractor, and then we show it all the tweets. So we end up with a vector space of 5,400 dimensions. So each tweet is now mapped into one such a vector. And then the next thing is we build a sentiment classifier model. So we use a standard model in one of the most popular models here, support vector machine. So we just define the parameters of the model and then fit the feature matrix that we extracted from the tweets. So this is a feature matrix, and the second step, the second argument is the vector of targets. So this is a typical classification problem. And so once we execute this fit method, we then get the model gets trained, and then we can predict sentiment on new tweets. So here we have cats are stupid text. So we first map it into a feature vector. So this feature space extracts sparse vector, and then we apply our SVM model on this vector, and that's basically it. And what we get is then it predicts a negative sentiment. And the next example there is what if we put text, cats are totally amazing, we then get a positive sentiment predicted. And now Blaz will show you the second example.
Okay, so the second example is a bit different. So here, what the task is to do the recommendation. So we'll implement a very simple version of people that viewed this also viewed that model. So we start with some input raw data. So here we have a bunch of people. Each person read one or more articles or lectures. Then we want to load this. We load it into a more structured representation. So we have two tables. One, we have a list of people. On the other side, we have a list of items. And we have maps between the who read which item or who viewed each item. And then in order to recommend, we take the one person, for example, this guy here. We check what he read so far. We check who else read these things. What else did they read? And then see and rank them by the number of counts here. And we get some ordering there. So green one is the candidate, so we would recommend the green thing, for example. Now, we use the internal storage representation we use allows for something we call probabilistic sampling. So even if you have millions of users or millions of items, you can still do this kind of joins in a matter of milliseconds. So that's so you can scale quite well. And for the examples, we'll be showing on page view data from one website called videolectures.net. So that's a website with lots of lectures, so from either undergrads mostly focused on the data analytics lectures. So there we collected over a period of a couple of months, we collected 4 million page views with 750,000 visitors and 13,000 lectures. And for the demo, so to run it on Tonic, we just focus on 10,000 visitors. But if you do it on a laptop like this, it still runs quite fine. And for each, from this data, we extract this simple mapping. So ID, this would be one user. So this ID would represent the user. And for this user, we have a list of all the lectures that he watched through. So kind of this error. And I will show the Tonic example. So again, this Tonic is public, so you can check it and clone it and edit it or play with it. So the way it starts is the same as before. We load QMiner, require QMiner and the data loader. Now here we have a bit more complicated schema. So here we have two tables. One is with visitors and one is with lectures. And they are connected by joins. So each visitor has a list of lectures that he viewed, and each lecture has a list of people that viewed that lecture. Now we import the data. So we have 10,000 visitors, and those 10,000 visitors watched in total 9,000 unique lectures. So some less, some watched only one, some watched more. And now we'll focus on one visitor. So let's call him John. So we select John, and we see that he viewed only one lecture, and the lecture was on a topic of fuzzy logic. Okay. Now let's see who else watched this same lecture. So we can say john.lectures.join shows, give me all the visitors to the lectures that John watched. In our case, only one lecture was in these lectures. And we see that there are 162 people that also watched the same lecture. Now we go on. From these people, what else, from these 162 people, what else did they watch? And here we say, okay, co-visitors.join lecture. So give me all the lectures these people watched. And 100 here means that we are only sampling 100 people from these co-visitors. And the sampling takes into account the weight. So if somebody would have more lectures in common with John, he would be more likely to be selected in the sampling. And we see there are in total 675 lectures watched by these people. And then we can first remove all the lectures that John already watched. So not to recommend him what he watched already. Sort by the weight. So the more of people like him, more people that watched the same lectures as he did, the more of them watched a particular lecture, the higher the weight would be. So it would be high. And we select top 5. And at the end, we can list this. And you see the top one would be, so fuzzy logic was kind of an introductory course, if we would go to check. And he suggested the introduction to machine learning and Gaussian process basics, so which actually correspond quite well. And if you would do, you can try this, if you would go and load, see if it goes, you would try to run again the npm, this tonic. Sometimes it works, sometimes it's a bit slow. Because right now we are on the unlucky side. So it takes a couple of seconds to go through the complete list here. And if you would go back to the, if you would run it on the complete data set, on this 4 million, it takes, on average, it takes like 5 to 6 milliseconds per user to generate recommendations. So it can be quite efficient. Okay, so these were two use cases. So they were quite chosen to be squeezed into these 20 minutes. But we and a couple of colleagues from the companies, they also tested the same framework in a couple of real-world applications, large scale. So when it's powering a recommendation on a website with tens of millions of users, and it takes on average 10 to 20 milliseconds per new visit to suggest a recommendation, so it's quite efficient. It's powering a website called Global Event Registry that's extracting events from a real-time feed of around 100 to 200,000 news articles per day. It was used on modeling road traffic on complete data from UK highways, and also on a couple of other projects. And it's available on npm and also on GitHub. So that's it. So if there are any questions. Yes, that's the idea. So one of the basic design principle was to make to start from the applications and go back and see what part of the machine learning or this kind of machinery you need to be able to do applications that we wanted to build that would be using machine learning. But there's you don't really need any R or any MATLAB or anything like that to start with. Yeah.
Do you have any other suggestions for getting training data sets? Publicly available training data sets?
Suggestions for publicly available data sets. So I have the links. If you go to the tonics that we have here, so these are two. Otherwise, Kaggle competitions would have lots of data sets. Otherwise, it's good checking from this conference, machine learning conferences. Sometimes they would be announcing these kind of things, but there's no one big that I would recommend, one big data set. I think we are done. Are there any other questions? Otherwise, we'll be around here tomorrow, so feel free to ask. Thanks.